In this video, I'm going to be working on this expression here on the left and simplifying it to this expression on the right using multiplication, division, factorization, and many other things. This is my second video on the simplification of exponents. The first video, the link, you can find it in the description. You can do this video first, but I highly recommend that you do the other one first, which is simpler and shorter, and then come back and do this one. This is the expression that I'm going to be simplifying. I have 5x cubed plus y to the 9th power, all of that multiplied by 90x with the exponent of -2 and y with the exponent of -5. And all of that is being divided by 36xyc, all of that in parentheses, cube, which is with an exponent 3. What's the first step? Well, if you look at the numerator, the top of the expression, and the distributive property, you can see that I have two expressions that are being added together, and all of that multiplied by a second expression, which is the one here inside of the rectangle. So if you can imagine, if you can visualize it, 5x cubed will be representing the a, y to the 9th power will be like the b, and everything that is in here is like the c. And I am going to change what I have inside of here into this side of the property. I'm going to change it into a multiplied by c plus b multiplied by c. So what I get now is what I call the a, which is 5x cubed multiplied by all of this, which is the c right here, and y to the 9th power multiply also by all of this, which is this side right here, and those two expressions are being added together. The second thing that I'm going to do is remember the property about fractions with similar denominators. If I have two expressions being added, say a plus b, all of that divided by c, I can rewrite it as a divided by c plus b divided by c. So if I call this a, if I call this b, and the denominator is the c, I'm just separating them. One expression divided by the denominator and the other expression divided by the denominator, and both of them are being added together. So far I haven't multiplied or done anything, just reorganized this expression so that I can simplify it later. The first thing that I'm going to work with is with the numerator of this expression on the left. 5x cubed multiplied by 90, x with an exponent -2 and y with an exponent -5. I multiply the numbers first. 5 times 90, which 5 times 90 equals 450. I multiply the x's together. X with an exponent 3 multiplied by x with an exponent -2. That equals a new x, and the exponent is nothing more than 3 from the first x plus -2 from the second x. And if I add 3 plus -2, that just equals x with the exponent 1. X with an exponent 1 is simply x. That's why I have x here and I don't have any exponent. The exponent is 1, but I don't have to write it. It's just equals x. And the y with the -5 exponent doesn't have any other y to multiply it with, so it just stays the same as y with an exponent of -5. So all this expression right here on the top left becomes 450 multiplied by x multiplied by y with an exponent of -5. Next step, I'm going to work on the top right, the numerator of the expression on the right. Same thing, y with an exponent of 9 multiplied by 90, x exponent -2, y exponent -5. I multiply the numbers, but I only have the 90, so it just stays the same, 90. The x, I only have one x, so it stays x with an exponent of -2. And I have two y's, y exponent 9 and y with exponent -5. I have to add the exponents, and the addition of that equals y with the new exponent is 9 plus -5, and 9 plus -5 is the same thing as 9 minus 5, and 9 minus 5 is 4. So all of this expression up here becomes 90 multiplied by x with an exponent of -2 multiplied also by y with an exponent of 4. So that's where we are up to now. The next step that I'm going to take is I am going to take the denominator of both sides, which is actually the same one, and I'm gonna apply the exponent, which is outside of the parentheses, to each one of the numbers and the variables that are inside of the parentheses. So 36, the exponent of everything in here is 1. So I have to multiply all of them by 3. The exponents by 3. What I'm saying is 36 had an exponent equal to 1, and 1 multiplied by 3 is just 36 cubed, or 36 with the exponent 3. And the same thing happens to all the variables. All of them get the exponent 3. So I have in the denominator now 36 cubed, x cubed, y cubed, c cubed, all of them with the exponent 3. Now that I get rid of the exponents outside of the parentheses, I can start simplifying terms in the numerator and in the denominator. The first thing that I see is that I have an x both in the numerator and in the denominator. What I can do with that is that equals x on the numerator divided by x cubed, or x with exponent 3 on the denominator. The rule about division of numbers with exponents says that that equals x, and the new exponent is going to be the exponent of the numerator minus the exponent of the denominator. So the numerator has an exponent of 1, which I don't have to write, but it's there. It's a 1, and the denominator has the exponent 3. So that becomes x with the exponent 1 minus 3, which equals x with an exponent of -2. And if you remember the rules about negative exponents, x with an exponent of -2 becomes 1 divided by x with the same exponent 2, but in this case positive. So at the end of the day, what we're left with is 1 divided by x squared. That's the result of the division of x by x cubed. Another way you can do that is simply saying that the denominator x cubed equals x times x squared. X cubed and x times x squared are equivalent. They're exactly the same thing. But now that allows me to see clearly that I have an x on the numerator and an x on the denominator. Here you see them one right on top of the other. When you have the same variables or the same number in the numerator and in the denominator, that equals 1. So this becomes 1, and I have the same result, 1 divided by x squared. The advantage that I see of this second method is that I have less of a chance of making a mistake of leaving the x squared in the numerator. Up here, if I say that 1 minus 3 is +2, I forget about writing the -2. Maybe I'm in a hurry and I forget about it. Sometimes I forget. I could leave the x squared on the numerator, and this has no x squared on the numerator. That will be a mistake. So here I have a little bit of less confusion because I know that the x is going to stay on the denominator and the one on the top is the one that's going to go. But my preferred method to do it is what I call the battle to the death. Both of these variables are going to go into a battle both go in, only one goes out, only one survives. Which one is the survivor? Well, it's easy, because the one that survives is the one that has the larger exponent. So in this case, the denominator, the one with x cubed, has a larger exponent than the one in the numerator, which has an exponent 1. So the survivor is the x on the denominator, because it has the larger exponent. But what is the value of the exponent now? Because it went into a battle, it suffers some losses, and the exponent is not going to be the same. It's actually going to be less. How much less? Well, it's going to be the exponents that the loser had. The one that disappeared had an exponent of 1. When it disappeared, it took that exponent 1 and also took one exponent 1 from the denominator, from the one winner, from the one that survived. So let's recap the battle here. These two go into battle. Which one is going to win? The denominator is going to win because it has the larger exponent. However, the number of exponents is going to be reduced. Reduced by how much? By the ones that this one possessed. By the ones that the one that disappeared had. So how many is that? Well, we had 3 to begin with. We had 3 to begin the battle, and we ended the battle with the ones that we had in the beginning, 3, minus the one of the one that disappeared. So 3 minus 1, that's why I have 2. What I like about this method is that I can quickly say, this is the one that's going to stay, the one in the denominator. This is the one that's going to disappear, the one in the numerator. And how much is going to be the value of the exponent of the one that survives? Well, what it had before minus the ones of the one that disappeared. 3 minus 1, 2. I prefer using this one because I don't have to write that much. I just know which one goes away, which one stays, and which one, and what is the value of the x, what is the value of the exponent of the x that remains. So after all of that discussion, the conclusion is that x divided by x cubed just equals 1 divided by x squared. And I place that here. Instead of having x divided by x cubed, I put 1 divided by x squared. But as you can see, I don't have the 1 in here because it is not necessary. It would just be 1 multiplied by all of this, and all of this multiplied by 1 just equals all of this. It will stay 450 multiplied by y with an exponent of -5. I don't have to multiply that by 1. So what I do is I simply get rid of the x on the numerator, and in the denominator I put x squared. And this is where we are up to now. The next step, I'm going to do the same thing but with the y. But the thing is that if I make the y's go into battle, we have a pacifist y here. Y with a negative exponent, if the exponent is negative, this y, instead of going to battle with this y, because of the negative exponent, it is going to join the y on the denominator. Remember, y with an exponent of -5 equals 1 divided by y with an exponent of +5. So the exponent becomes positive and goes to the denominator. And instead of going to a battle, what I have now is 1 divided by y cubed times y to the 5th power. And that becomes y to the 8th power. When you have similar bases, different exponents, you keep the same base and you add the exponents. So y with an exponent of -5 divided by y, an exponent of +3, becomes 1 divided by y to the 8th power. And that's what I put in here. I forget about the 1, it is not necessary, you don't have to write it, and I put 8, and I put y to the 8th power on the denominator. That's where we are up to now. Next thing I'm gonna do It's the same thing on the other side. On the right side, I'm going to work with this pair of x's. The same thing happens here. The x on the numerator is -2. The x on the denominator is 3. I mean, the exponent of that x is 3, it's cube. So x with an exponent of -2 becomes 1 divided by x squared with the 2 positive. So this expression becomes 1 divided by x cubed times x squared. The exponents add up, and that's just 1 divided by x, and the exponent is 3 plus 2, 5. So the x on the top disappears, and in the denominator I have an x with an exponent of 5. Here we are up to now. Now I'm going to do the same thing with the y's. In the y's, we have y with the 4th power on the numerator and y cubed on in the denominator. Now, here we have a battle again. These two really want to fight. So, we have a fight here. Which one will survive? Survives the one with the larger exponent. This one disappears. The one in the denominator goes away. But how many exponents remain for the survivor? The survivor only can retain one exponent, because this one that disappears took away 3 when he disappeared. So the new exponent is 1. We have y with an exponent of 4 minus 3 from the one that disappeared equals 1. And in the denominator, I can put a 1 if I want to. And here in the numerator, we have y with an exponent 1. I don't need the 1. Y with an exponent 1 just equals y. And y divided by 1 also just equals y. So at the end of the day, y with an exponent 4 divided by y cubed just equals plain and simply y. And that y, the reason that I wrote the 1 so that you can see clearly that the y goes in the numerator. You don't have to write it over 1, but here you can see clearly that the y goes in the numerator. So I go below, and where I had the 2 y's before, now I have 1 y in the numerator. That's where we are up to now. A little more organized, I would say, than when we started. Now, what I'm gonna do now is do a little bit of factorization. And in order for you to remember, I'm gonna do basically the distributive property backwards. I have 2 terms that are being added together. Each one of them has a c being multiplied, a times c and b times c. So what I can do is do this backwards and take the c outside of this expression, and then the c gets multiplied by the parenthesis a plus b. Before, I multiplied the c by a and then the c by b. Now I'm going to go backwards. If I find something similar in both terms that are being added together, then that thing that I found that they have in common is the thing that I'm going to take outside of the parenthesis, which is this parenthesis that I just wrote in here. Before I start doing that, I'm going to rewrite the 450. Remember that first we multiplied 90 by 5 and it was 450. When now I see that it is convenient for me to keep it as 90 times 5. So I'm going to rewrite it 450. I'm going to write it back as 90 times 5, because if I do that, now I have 90 in this term and 90 in this term, and I can take the 90 outside of the parenthesis. Here you can see 450, 90 times 5, and now I have the 90 outside of the parenthesis. If I want to go back, it becomes 90 times 5, which is 450, and 90 times y, which is 90y, which is what I had before. So now I have taken the 90 as a common factor and taken it outside. Now I am going to work with the denominator. what things I can find that are in common in the denominator of both of these fractions. Well, first, before I do that, I'm gonna rewrite x to the power of 5 back into x cubed times x squared. The reason I'm gonna do that, well, you're gonna see in the next step. The reason I separate them is because now I have in common 36 cubed here, 36 cubed here. I have x squared here, I have x cubed, which is not common, but right next to the x cubed I have the x squared, which I just wrote back, and the c cubed and also the c cubed. So I have 3 terms on each side that I can take out of the parentheses, take away from these denominators, and put in the denominator of the fraction outside of the parentheses. If I take these terms out from this denominator, the only one that remains is y to the 8th power. All of the other ones are being taken outside of the parentheses. And on this side, if I take the similar terms out, the only one that remains inside of the parentheses is x cubed. If I want to go back, I just have to multiply this by y to the 8th power, and I get this back again. Same thing on the other side. Multiply x cubed times all of this expression, and I get all of this back again. So now I organize it a little bit, and we see that there's nothing more than I can simplify inside of the parentheses. I cannot do anything with the numerator and the denominator. They are simplified. I cannot do anything here, and I cannot take anything out as a common factor. So this part is as simple as it can be. Now I can simplify the new fraction that I made on the outside of the parentheses. To do that, I'm gonna write 90 as 18 times 5. These two are equivalent. 18 times 5 is 90, but it's convenient for me to write it as 18 times 5, as you will see very soon. And in the denominator, I have 36 cubed. 36 cubed equals 18 times 2, all of that in parentheses, cube. So I can apply the cube to each one of the numbers that are being multiplied. 36 cubed equals 18 cubed times 2 cubed. If you're having a little bit of doubt with that, check it in the calculator or do it by hand. 36 cubed equals 18 cubed times 2 cubed. The reason I do that is because now I can make the two of these two 18s go into a battle, just like the x and the y's did before. I have an 18 on the numerator, I have an 18 on the denominator. They have different exponents. Only one of those 18 is going to survive. Which one of the 18s is going to survive, the numerator or the denominator? Well, it is the denominator because it has the larger exponent. The larger exponent is 3. The exponent on the numerator is 1. So the exponent of the survivor is going to be what I had before, 3, minus the exponent of the one that disappeared. The one that disappears from the numerator had an exponent of 1. So my new exponent is 2. 3 from here minus 1 from here. So I end up with 18 squared on the denominator and just 5 on the numerator. What else is there to do? So what I'm gonna do now is I'm gonna rewrite 2 cubed and rewrite c cubed. These two I'm gonna rewrite as 2 squared times 2. 2 squared times 2 is the same thing as 2 cubed. And c squared times c, again, is the same thing. But the reason I do it, as you will see in just a moment, first of all, the 2 without an exponent, or with exponent 1, the 2 and the c, I'm going to move to the front. All of those terms are being multiplied, so changing the order doesn't change the results. A times b equals b times a. Changing the order of multiplication does not change the final result. So I move the 2 to the front of the pack, and the c I put right next to it. When I do that, you're going to see that everything after 2c has an exponent of 2. I have 18 squared, 2 squared, x squared, and c squared. So what I can do is simply put a parenthesis outside of all of that and put the square, the exponent 2, on the outside. Now these two expressions are equivalent. If I take the 2 and distribute it among the members inside of the parentheses, I get what I had before. But now, instead of having the squared 4 times, I just have it once outside of the parentheses. And then we have inside of the parentheses 18 times 2. And 18 times 2 is nothing more than 36. So what I end up with is 5 on the numerator, 2 times c on the denominator, and that is multiplied by 36 xc in parentheses squared. So as I said before, there's nothing more to simplify here. Of course, there's nothing more to simplify in the numerator, it's just a 5. And in the denominator, I cannot cancel anything with the numerator, so it is as simple as it's going to get. You can this is what we had at the beginning, the expression that we started with, and this is the expression that I told you that I was going to show you at the end. This part right here, you could also write it like this: 5 divided by 2592 x squared c cubed. These two terms are equivalent. You can write it like this, or you can write it like this. Which one is the most simplified? Well, I'm gonna leave it up to you. I'm not gonna tell you how to get from this side to this side, because by now you should know. It is very simple, and I'm gonna let you do it, let's say, as a homework. This is what we began with. This is one of the possible solution, or the possible simplification, and this is the other possible simplification. Which one is the best simplification? I leave that up to you.